Well, you need to know. Well, tomorrow is the test. Hopefully, you've been doing stuff. So all we're going to do today is discuss problems. So you might as well put a lot of problems on there if need be. Huh? I'm going to do every single one.
But I thought you said you'd do all of them if they're on the
Okay, prove to me that you tried every single one that I went. Part? It's at home.
Mr. Park, are you gonna play with the orchestra today? At 3:05?
No? No, I think Mrs. Werman told me period 1. What are you talking about? Talking about Phantom of the Opera.
Yeah.
Yeah, period 1, I'm going to tell you.
Tomorrow?
No, well, she's going to tell me which period 1 is tomorrow. I don't think it's tomorrow.
I don't know. That would be awesome.
Well, I tell you what, since this is period 6 and we're videoing, I can do every single one. No, if I'm going to do all, I'm going to do them in order. Okay, well, number 1, can everybody do number 1 then?
Yes.
Yeah.
Si, senor.
Saka is holding up a finger.
Can I eat?
I'll hold up a finger. You want me to hold up a finger?
No.
So what?
Can I eat?
Yeah, I thought you meant you want number 1.
Oh no. I did number 1.
Okay, so let's start with number 2 then. And you watch, you give number 1 in tomorrow's test, so watch what's going to happen. We'll see. Okay, 32 tickets are numbered from 1 to 32 and placed in a box. If one ticket is randomly drawn, what is the probability that the number is divisible by 2 or 3? What's the denominator going to be? There's 32 tickets in the box. I'm going to randomly pick one. What's the denominator?
32.
Okay, 32. Who said 6? The denominator 6? What's the probability that it's divisible by 2 or 3? Well, out of the 32 numbers, how many of them are divisible by 2? Do I really have to count, write them all out? 16. How many of them are divisible by 3? 3 goes into 32.
I mean,
10 times. And of course the word or implies adding. But Mr. Park, that's not the answer. That's because we counted some of them twice. So this is where you gotta use common sense. So we have to subtract the ones that you actually counted twice.
5.
The ones that are divisible by both 2 and 3.
5.
If a number is divisible by both 2 and 3, that means it's divisible by 6. So how many numbers are divisible by 6? 5.
Oh.
Isn't that just common sense? Like how many people are in this room? 1,000,000, because I counted Morris 999,974 times. You can't do that. I put a common sense problem there, I'll help roll loose. What does that mean? 2 tickets are randomly drawn. Find the probability that the sum of the 2 numbers is less than 10. What's the denominator going to be? If I'm in a good mood, I might actually give you 1 point for the denominator tonight. If I'm in a good mood. But since I'm correcting period 6 first, probably not. Especially this Morris is on top of the pile. What's the denominator? 32 in a box, and I'm going to randomly pick 2. 32, choose 2. Okay, now how many of these are so that the sum of the numbers is less than 10? Now sometimes there's just no formula. You just have to count them by hand. And this is one of them. So what are the numbers that the sum is less than 10? 1 and 2, or 1 and 1? No, you can't get a 1 and a 1. There's no 2 1 tickets in there. 1 and a 2, 1 and a 3, 1 and a 4, 1 and a 5, 1, 6, 1, 7, 1, 8. Less than 10, right? Or less than 9, less than 10. So now we go to the 2s. 2, 3, 2, 4, 2, 5, 2, 6, 2, 7. Now we go to the 3s. 3, 4, 3, 5, 3, 6. Now we go to the 4s. 4, 5. That's it. Count them. 1 plus 3 plus 5 plus 7.
What about that, like switching?
Okay, wait, let's just write down the answer first and then I'll get mad. 1 plus 3 plus 5 plus 7.
16. Oh, never mind, I see it.
But what about, okay, so Morris is saying, what about the 2 and the 1 and the, what about switching it? Well, look at the denominator, you pulled out 2 and 1s. There is no order. However, if you made the denominator 32 times 31, then there is an order, which means now you gotta count 1 and 2, and then 2 and 1. You see? You cannot count the denominator one way using combinations and then count the numerator using permutations. That's an automatic fail error. If you do combinations in the denominator, you gotta do combinations for the numerator. You know what I'm talking about? Cannot mix them. It's like mating a dog and a cat. It probably can't be done. Okay, now 3 tickets are randomly drawn. What's the denominator gonna be? You gotta be joking.
32.
Okay, thank you. 32, choose 3. At least get the formula tomorrow because you guys' computations are just atrocious. Find the probability that the product of the 3 numbers is even. Now what the heck does that mean? If I multiply 3 numbers together and get an even number, what has to be true?
At least one of them is even.
At least one of them must be even, right? So you could have even, odd, odd, you could have 1 even, you could have 2 evens, or you could have all 3 evens. So maybe it would be better to do the complement. No evens and subtract that from 1. And of course, if you don't have any evens, that means they're all odd then, right? So how many odd numbers are there in the box?
16.
How many ways can I pick 3 of them? 16, choose 3, and then just subtract that from 1. And there's your formula, you got 3 out of 4 points. And we're just doing the rest, because we're period 6. 3 standard dice are rolled, find the probability that the sum of the 3 numbers showing is equal to 15. See, we are already past 2 dice being rolled, that's automatic already, right? 3 dice being rolled, what's the denominator gonna be? 216, but you gotta remember now, this is like, you got a first roll, a second roll, and a third roll, so this is, the denominator is a permutation. So that means the numerator gotta be a permutation too now. Okay, the sum of the numbers is equal to 15. Okay, how can you get a 15 when you roll 3 dice? Give me one case.
1 through 5.
A 1, a 3, and a 5?
6, 3.
They add up to 15. I was thinking a 4, a 5, and a 6. But how many different orders can you put them in? No. 6. How many ways can you arrange 3 people in a row? 3 factorial, 6, right? Is there another way I can get the 3 numbers adding up to 15? Yeah, how about a 5, a 5, and a 5? How many different orders can you put them in? 1. There's only 1 order. It's like how many 3-letter words can you make, right? Is there another way I can get the 3 numbers adding up to 15? 6, a 6, and a 3. But how many different orders can you put them into? 3. That's like how many 3-letter words can you make with 2 A's and a B, right? So 3. Boom, there's your answer. Okay, I can pretty much guarantee you can throw 3 dice tomorrow, maybe 4. Who knows? If it's 4, then the denominator is 1296, right?
Wait, how do you?
6 times 6 times 6. So if it's 4 dice, 6 times 6 times 6 times 6. So since I told you that, it can be 5 dice. 6 times 6 times 6 times 3. You guys have problems extending, yeah? No crinkling. Number 4. The probability that Bert beats Ernie at a particular game which there are no ties, is 2/3. So this is like tossing a coin, except the probability of getting a tail is 2/3 or something. They play 4 games, that's like tossing it 4 times. What's the probability that Ernie wins at least 2 games? This is binomial probability. So what does at least, and remember on the last quiz, a lot of you didn't read the word at least
Yeah.
2? So what does at least 2 games mean? 2, 3, or 4. Now, is it better to do that or the complement, which is 1 or 0 and subtract that from 1? Well, in either case, you gotta do 3 computations but subtracting from 1, some of you have a hard time now. So maybe we should just do it directly. So 2, 3, or 4. How many trials are we doing in this problem? So n equals 4. What's the probability of a success? It says the probability that Bert beats Ernie. Oh, so we want the probability that Ernie wins.
Yeah.
So 1/3 then, right? So therefore, its failure is 2/3. So if you want 2 successes, it's going to be 4, choose 2, 1/3 to the 2, 2/3 to the 2. If you want 3 successes, 4, choose 3, 1/3 to the 3, 2/3 to the 1. And then 4 successes, 4, choose 4, 1/3 to the 4, 2/3 to the 0. At least write that down on your paper, because I know computation is a problem for you. Number 5. 3 children and 3 adults are randomly seated in a row. So this is a permutation, because we're arranging people in a row. Tell me, what's the denominator? How many ways can you arrange 6 people in a row? Can I just write 6 factorial like that then? Or do you want to write 6 by 4, 3, 2, 1, so you can start canceling? I don't care what you do. 1, 2, 3, 4, 5. Do whatever you want. Okay, now, the children cannot sit next to each other. I believe this problem was on the last test. This test, all you're doing is adding a denominator. Almost all the problems you see here are like the last test. You're just putting in a denominator now. That's the only difference. Okay, so let's do a specific case. What if the children sit in seats 1, 3, and 5 right there? Here are the 3 children. How many choices do I have?
3.
3, 2, 1, and then the 3 adults. 3, 2, 1. And here's the most important part, which is worth 3 points. Is that the only case where the children are separated? They sit in seats 1, 3, and 5? No, Moose Breath. So what are the other cases? They could sit in seats 1. Why don't you do it systematically? 1, 3, and 6. 1, 4, and 6. 2, 4, and 6. Are there any others? So you multiply by 4. Now you let the cancel. See, there's no formula. Sometimes there's no formula. Sometimes you actually gotta count it by hand. That's what you guys don't like, yeah? Ooh. Okay, number 6. This is the birthday problem. The probability is 1 that this is on tomorrow's test. If anybody misses the birthday problem tomorrow, take off triple. Oh, but then again, you guys are gonna miss it. You know why? Because I put a lemony twist in it. It'll make it more refreshing. You don't want to just do the same dumb problem over and over, right? Oh, are you? You're sleeping.
Because it can be like at least 3.
No, you wouldn't be able to handle at least 3.
Okay.
Okay, planet Zix has 8 days in a year. You have 5 inhabitants. Okay, you guys already know how to do the birthday problem, right? It's like this. 1 minus, there's 5 people, you put 5 parentheses. Do I have to dumb it down for you like that? Apparently. There's 8 days in a year. So what goes in the first one? 8 over 8, 7 out of 8, 6 over 8, 5 out of 8, 4 over 8. That's your answer. We've done this birthday problem how many times already? Some of us none though. Number 7. A 3-digit number is randomly built from the digits A. I remember this from last chapter. You gotta do something, yeah? Oh, find the probability that the number is divisible by 5. Well, I was thinking it's gonna be even. Ooh, maybe that's tomorrow's one. Anyway, divisible by 5 is the same thing. What's the problem here? 0, 1, 2, 3, 4, 5, 6, 7. The problem is the 0. So what do we have to do? We gotta make 2 cases, just like last chapter. What are the 2 cases? 0 is the last digit, and 5 is the last digit, because the number is divisible by 5, right? So if 0 is the last digit, you have 1 choice. Once you use the 0, how many choices do you have for the first digit? 7 and then 6, because it says you cannot repeat, right? Yes. Now, if 5 is the last digit, you got one choice. How many choices do you have for the first digit?
6.
6, and then now you can use the 0.
6.
6. You have to make 2 cases, otherwise it's minus 4. Maybe I should make it 5 tomorrow. Minus 4 is too lenient. It's gonna hurt. Now, we did this last chapter. The only difference now is there's a denominator. You do a permutation on the top, you better do a permutation on the bottom. How many 3-digit numbers can you make using these numbers? 7 choices. Now you can use a 0. 7 and then 6. Now, some people came in for help asking, and they couldn't get from here to the answer. You know what the simplest way is? Factor out a 6 on the top. If you factor out a 6 on the top, you get 7 plus 6, all over 7 times 6, and then you can cancel. So you get 13 over 49, finished. Isn't that a lot better than going, 42 plus 36? But that's all I know how to do. Whatever. Number 8, this is the prom problem we did. You guys remember the prom problem? Love benches?
Yep.
Okay, 4 married couples are randomly arranged around a circular table. Okay, this is last chapter. So, since the couples have to sit together, you put them on benches. How many ways can I arrange 4 benches around a circular table? N minus 1 factorial, 3 factorial. But on this bench got 2 people. This bench got 2 people. This bench got 2 people. We did that last chapter. This chapter, we just have a denominator now. How many ways can you arrange 8 people around a circular table? 7 factorial, and there's your answer. Just throw in the denominator and you're done. Okay, ooh. Number 9, does anybody recognize that problem? Like the last quiz we took? Didn't I use the exact same numbers, 5 red and 2 black tokens? And we gotta do that again? Okay, I will. What's gonna happen when you go to BC next year? When you gotta hand in homework every single day? When there's no practice tests? On the day of the test, you have homework due the next day? What's gonna happen?
You're not gonna graduate.
Go to Mr. Park.
Okay, we got 5 red and 2 black tokens. Fred and Barney take turns. The first person to draw the black token wins. If Fred goes first, find the probability that Fred will win. Okay, how can Fred win? I think on the quiz I made Barney win, so I put Fred here, you can't do it, right? Even with the same numbers. Okay, Fred goes first. How many ways can he win?
3.
He pulls up that black marble right on the first one. What's the probability of that happening? 2 7s. Okay, is there another way Fred could have won? Yeah, he pulls out the red, Barney red, and then Fred pulls out the black on the third draw. What's the probability of that happening?
5.
Notice we're going one at a time here.
5
5 7s,
4
4 6, and then now the black.
2 6.
2 what? 2 fifths.
Fifths.
2 fifths. When you pull out a marble, there's one less marble in the thing every time now. Is there another way Fred could win? Yes, Fred, Barney, and then Fred pulls out the black on the 5th draw. I remember on the quiz, some of you had another case. It was crazy. 5 7s, 4 6, 3 5ths, 2 4ths, and now the black. 2 thirds. Some of you actually had another case in there. I can't believe my eyeballs. And then what do I do with these numbers? You add them because there's a big space between them. That's exactly from the last quiz. I can't believe it. Now, number 10, same problem, except you replace the tokens. Remember I told you about this? Okay, what's the probability of getting a black on first draw? Quick!
7.
Okay, now, what about red, black? 5 7s, put the marble back in. 5 7s, and now the black. Okay, what about this one? 5 7s, put the marble back in. 5 7s, 5 7s, 5 7s, and now the black. 2 7. Yeah, but Mr. Park, doesn't this go on forever? Because you keep putting the marble back in?
Yeah.
Yavo! Which means yes, in some language. How do I have an infinite number of things, Mr. Park? Well, I taught you. What is this? This is an infinite geometric series. What is the common ratio? What do I need to multiply by to get the next term?
25 over 49.
25 49s. Is the Is the absolute value of that less than 1?
Yeah.
Yeah, so I can use the formula. The sum of an infinite geometric series is the first term over 1 minus the common ratio. That's the answer. But you can only use this formula if the absolute value of that is less than 1. Remember I showed you why? Or do I have to show you again? It's a very powerful formula. First term over 1 minus r. The sum of an infinite geometric series. Oh boy. Number 11! There she blows! Didn't we do facetious last chapter? No, we did abstemious. Do you remember that? You cannot even remember like key things. Abstemious. See, there are certain words I like to use. Abstemious, facetious. Can you think of another word that has all 5 vowels in it? No. I told you to. Equation. I love to use those 3 on test. Okay, here are the letters of the word facetious are randomly scrambled. What's the probability that the vowels will appear in alphabetical order? Remember doing this problem last chapter? Alphabetical order. Okay, let's do the numerator, because the numerator is exactly what we did last chapter. How many letters are there in facetious? Rhymes with mine.
9.
It's a permutation, right? Because we're arranging the letters. We want the vowels to be in alphabetical order. So let's do a specific case. What if the 5 vowels are in the first 5 positions? How many choices do I have? 1, 1, 1, 1, 1, because that's the A, E, I, O, U. They have to be in alphabetical order. Now the 4 consonants, doesn't matter what order, so it's 4, 3, 2, 1. But, and here's the most important part of the problem, is that the only way the vowels can be in positions 1, 2, 3, 4, 5?
No.
What about 1, 2, 3, 4, 6? What about 1, 2, 3, 7, 0? What about 2, 3, 5, 0? 9, choose 5, right? Out of the 9 positions, how many ways can I pick 5 of them to be the vowels? Or it could be how many ways can I pick 4 of them to be the consonants,
Why
right?
is it 5?
Because it's got 5 vowels.
Oh, that.
But it doesn't matter, you could have put 9, choose 4, because it's the same thing, right? We did that last chapter. The only thing different now is now we have a denominator. How many ways can you arrange 9 letters all in a row? 9 factorial. See, you do a permutation on the top, you better do a permutation on the bottom, sister. And you can expect a few card problems tomorrow, too. Yeah. 2 cards are randomly drawn from a standard deck. If both are face cards, oh, so this is, what do you call this kind of problem? Expected value. That was last night's homework. You guys just, I want to hurt you. 2 cards, if both are face cards, you win. If you get 1 face card, you win. Otherwise, you lose. Okay, so 2 face cards. So this is what you got to do. 1 face card, and then no face cards. Okay, so we got to compute the probability of these 3 things. Now, how do you want to compute these probabilities? Pull out the cards 2 at one time, and you want to go 1 and 1. Now remember, you pull it out 1 at a time. There's an order, so you got to multiply by the number of orders now. If you don't multiply by the order tomorrow, there's big points coming off. So which way? I don't care which way. That's all. You just got to do it. Or I'll do it both ways for you. What's the probability of getting a face card on the first draw? Face card and then face card. How many face cards in the deck? Rhymes with 12. 12. 52. And then another face card, 11 out of 51. Is there any other order I can get 2 face cards? No, so that's it right there. If you want to do the pull it 2 at once, you just go how many face cards are in the deck? 12. How many ways can I pick 2 of them? 12, choose 2, boo boo boy. And then on 52 cards, how many ways can I select 2? 52, choose 2, boo boo boy. And that's the same thing. Okay, let's simplify that. 4 goes into that 3 times, 4 goes into that 13, but 3 goes into that 17, so that comes out 11 over 221. Now you can see why I picked those numbers. What about 1 face card? Well, let's do a specific case. Face card on the first one and not a face card on the second. What's the probability of that happening? Face card. Not a face card.
40.
40 out of 51. However, is that the only order you can get one face card? No, there's two different orders, so you gotta multiply by 2, sister. So 4 goes into that 3, 4 goes into that 13, but 3 goes into that 17. And that's all. So 80 out of 221. And then no face card, so not a face card on the first, not a face card on the second. What's the probability of that happening?
40.
40 out of 52, 39 out of 51. Is that the only order? You can get 2 non-face cards? Yes, so that's it. So 4 goes into that 10, 4 goes into that 13, but 3 goes into that 13 and 3 goes into that 17. So we got 130 over 221. Now, you know how you can check to see if you did your probabilities correctly? Do they add up to 1? Yep, they do. I need a little more space here. So, what happens if you draw 2 face cards? You win $884. See, because then that goes into that 4 times and make it pretty. If you won't get 1 face card, you win $221. And if you don't get any face cards, you lose $221. I just got 5 out of 6 points right there. This problem is going to be worth more because you got to do more computations. So 3 separate problems. And then finally, number 13. A mathematician drives to work 5 days a week. How would you describe this problem? What category do I put this in?
Tree.
Yeah, but what is it called? Is that what you call it? The one you gotta draw the tree. What is it called? Conditional probability. What are you guys gonna do when you go to college? They're gonna say, what school you came from? Castle. Castle High School. Okay, so if I read this, on a particular day, the boss noticed that she arrived on time. What is the probability that she took the leaky highway that day? So what are we trying to find? The probability that she took the leaky highway, knowing that she came on time. You gotta be able to read that and translate. So what is, according to the theorem, this is equal to the probability on time and you took the leaky divided by the probability on time. See, at least some of you are seeing patterns. Hey, whatever one goes there, that's the one that goes there. Some of you still hazy. Okay, so here we go. You drive to work 5 days a week. You take leaky and poly. So leaky, poly. Sometimes you take the leaky, sometimes you're on time, and sometimes you're late, not on time. You take the poly, sometimes you're on time, but sometimes you're not on time. So you gotta fill in the tree. What's the probability of picking leaky?
3 cents.
No, time out. Morris!
3
Because you heard her say it. Yes, you lying then. So what the other teacher said is true.
What?
Nothing.
What?
2 fifths. What's the probability of being on time?
My iPad's dead, I'm sorry.
I'll tell you what's gonna be there.
I'm kidding.
Are you open that iPad now?
No, it's really dead.
Come on, then just give it to me, I'll throw it away for you. Leave!
3 fifths.
80%. 8 cents. 4
Or
fifths.
8.
4 fifths.
George is not happy. Fill in this part.
3 fifths.
And so that's 2 fifths, right? So, what's the probability you're gonna be on time and you took the leaky highway? So right here, down yonder, 3 fifths times 4 fifths. How many times have we done this on the board? It's like embarrassing. What's the probability that you're on time? Well, there's 2 ways you can be on time. You can go leaky and be on time, or you can take the poly and be on time. 3/5 times 4/5, and the other one is 2/5 times 3/5. And if you can't compute that, I just laugh at you tomorrow already. Multiply top and bottom by 25, come on. You wanna just go back and do number 1 for funsies, since we have time? Okay. You're supposed to say no! Alright, next year I don't have to teach BC, I don't have to see you. Number 1. Oh, but then again, I might have some of you in AB.
You should just pass this.
It's gonna hurt. Okay, in the jar, maybe I just won't teach calculus. 5 red, 4 blue, and 3 green. You know how refreshing it is to teach Algebra 2B? Because I don't expect anything. So I just laugh when they don't do their homework. Actually, they do their homework, you know. 4 are randomly drawn. What's the probability of getting 2 blue and 2 green tokens? I'm going to explain this, okay? There's 2 ways you can do this problem. Drawing one at a time. Okay, let's do that one first. We want 2 blue and 2 green. So let's do a specific case. Blue, blue, green, green. What's the probability of this happening? 4 12s times 3 11s times 3 10s times 2 9s. However, is that the only order you can get 2 blues and 2 greens? No, so how many 4-letter words can you make with 2 B's and 2 G's? 6, okay. However you count it, it's 6, okay. But you have to multiply by the number of orders. The other way to do the problem is just pull out all 4 at once. So the denominator is going to be 12 choose 4. And then we want 2 blues and 2 greens. So out of the 4 blues, how many ways can I select 2 of them? 4 choose 2. And then out of the greens, I'm going to pick 2. 3 choose 2. So you do it either this way or this way. Tomorrow, if you do it this way and then you multiply by 6, I'm going to take off 18. 1. 181 I take off for that. You guys understand why you don't multiply this one by the number? Because there's no order, that's why you just put it on. And then B, at least 1 red token. What are you going to do tomorrow when you see the phrase at least 1? You do the complement. What's the complement of at least 1 red token? No red tokens. So, what's the probability of getting no red tokens? How many tokens are not red?
7.
How many ways can I pick 4 of them? And then the total is 12 choose 4, and then subtract from 1. In fact, I think some of you should just write that down and go to the next problem, right? Because computation might be a bear for you. Okay, we still got time here. Let me look at something that might help you tomorrow on the other one. Why is it so warm? Okay, look at number 9. Okay, we haven't done a problem like number 9 yet. What if I spring something like that on you? Are you gonna pounce on it like a wounded tapir? Or are you gonna cower in the bushes? Probability 7, number 9. What are you gonna do? Cower in the bushes, or are you gonna pounce? Cower in the bushes, let somebody else kill the tapir, and then you come out and eat the scraps.
That's how you survive.
A tapir is like, isn't it like this thing with the long snout? Okay, wildebeest then. Are you gonna pounce on the wounded wildebeest, or are you gonna cower in the bushes? Please help me. Help me! Help! I shouldn't yell help yet, that's bad.
What if someone actually
That would be bad to yell.
What if someone actually comes?
Well,
Was it not?
Y'all just kidding.
Someone could be worried.
just gonna make sure. Everybody okay? Yeah, you know. Probability that A will solve a puzzle is 2/5. The probability that B will solve the same puzzle is 3/7. if both A and B are working on the puzzle, what's the probability the puzzle will be solved? Now, I know how to do it, can you do it? Okay, think. How will the puzzle be solved?
If one of them does it.
A solves it,
Or B solves it.
or B. So, what if both of them solve it? Yeah, so there's three cases. A solves it, B doesn't. A doesn't, and B does. And A and B both solve it, right? So that means at least one of them gotta solve it then, right? Oh, at least one. What do I do when I see the phrase at least one? Yeah, do the complement. So compute the probability that nobody solves the puzzle and subtract it from one. So what's the only way that the puzzle will not be solved? A doesn't solve it and B doesn't solve it. What's the probability of that happening? I forget the numbers already. So if the probability that A solves it is 2/5, then what is it? Doesn't solve it. We cannot even subtract from one, and then B,
Or solves it.
and then subtract from one. Or, like I said, you can do this. A solves it, but B doesn't. A doesn't, and B does. And they both do. Here, just for funsies, let's just do this for funsies. Go! Fill in the numbers. Morris, redeem yourself.
2/5 and 4/7.
Yeah, please continue.
2/5, 3/7.
Okay, so if you compute this, this is 1 minus 12 35ths, which is 23/35, correct? Cancel the 3's 2/5. And then this one is 8 35ths plus 9 35ths plus 6 35ths, which is 27 plus 6, 23 35ths. You get the same answer. Duh, you should get the same answer, right? So how many of you would have pounced? See, at least Soft is raising his hand today. He's not sleeping. Okay, we're done. I'm done with you. No, I'm serious. You guys are going below period 3. Period 3, like you guys, I don't know. At least you guys have an excuse, I guess, because after lunch everybody's like gone dead, right? What is period 3's excuse? They just stare. That's all they do is stare. And then when I call on them, they pretend that's not their name. They do that all the time. Right, period 3? Period 3, I'm talking about you. Yep.
Didn't you cross out like two